Hi there, welcome back. What you're seeing here is me reacting to one of my greatest fears when doing restoration. I told you before in previous videos that I always fear finding a blown power transformer or output transformer, but the one thing I fear most is breaking a dial glass. So the first thing I tend to do is remove it and put it somewhere safe, because if those things break, you're in for a hell of a job trying to recreate it. Usually it's not quite possible to get a replacement, and sometimes when you do, they arrive broken anyway. So just get that out of the way and avoid a lot of heartache. So I removed the dial plate and I noticed something immediately which got me focused on repairing. I'll show you in a second. And this is just to say that when doing these restorations, I do try to follow a set order, you know, power transformer, output transformers, check the power supply, blah, 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 blah. But as you go along, little things come up, and that's the whole point of a hobby. You just do what you enjoy. And one thing I do enjoy is when I find something that I can repair right away, I do that. And what I did here was repair something that would have caused a lot of heartache, which is the dial cord on the FM section. If you recall, the FM section was not working at all when I rotated the tuning, and I found out why. What you see there is the dial pointer of the FM down at the bottom. And if the spring looks new, it's because it is. When I opened it up, I noticed that the spring was gone. So when you turn the tuning, it just wasn't grabbing at all. And I did notice that the actual dial cord was wound in the right positions. And just to avoid a lot of heartache, because these dial cords can be a real pain in the ass to sort out, I decided to tighten it up. And when I did that, I didn't get it tight enough the first time round by just replacing that spring there. So I rewound this. I wound it again around this. This had two windings or one winding. I put another one on there. And what it serves to do is to make the dial cord a little bit shorter and therefore tighter. Therefore the whole thing becomes more functional. And I'll show you, it actually works now. When you tune the outer one, if you recall, that's the AM, and you can just see in the background there the AM condenser is moving. And when you tune the inner one, that's the FM. And as you can see, the dial pointer is working, and so is that turning there. So the dial cords are in place, and hopefully I won't have to do any replacing of that, because as I said, it's a real pain in the butt to get those all wound right. There are drawings. I've got to tell you, I found a schematic. The one I had was very, very vague. You could hardly see you couldn't see the component values. And I managed to find an actual scan of an original. It's in that old yellow color. So this thing was something somebody did with a lot of care. And I've got that whole thing. It's a whole service manual with a full schematic. So it's all in German, but hey, that's not a problem with Google Translate. And I know I'm ready to get started on this. So first things first, took the dial glass off, repaired that. As you can see, this thing is pretty rusty. So that gives us a chance to remove that and paint that as well. Clear the rust out first, obviously. And tested the power transformer, which was done using the method that I've described in one of the building blocks, and I'll link above if anybody's interested. So the power transformer seems to be okay. I tested the two output transformers as well. They're working. So we've got the building blocks. The main building blocks are fine. And the next step was to see what the filter capacitor was like. Now, the filter capacitor, which is that thing over there, that can, has two capacitors in there. One is 100 microfarads and the other one's 50 microfarads, both at 350 volts. And what I generally do is I test them. They seem to be okay in terms of value. One was reading 94, the other one was reading 40 something. The ESR was pretty low, but I did find a problem. I tried to reform them or tested them for leakage on the component, on the capacitor leakage tester and reformer, which is this thing here, which is a project I built, and there's also a link above if you want to look at the project. This thing is proven very, very useful to measure leakage, and it also can be used to reform electrolytic capacitors. I tried to reform them, left them there for a few hours. The leakage current on the 100 microfarad started pretty high. It started dropping. A few hours later it was down at 20 milliamps. Beg your pardon, to 2 milliamps. It was reading on the 20 on the 10 milliamp scale. And then it started going up again. So obviously the reforming process was not working the way I wanted it to. So I'm going to have to actually restuff that capacitor. And if you don't know what that means, it means removing this thing, opening the bottom up, removing the gunk that's inside that actually represents two capacitors, and putting two new capacitors in there connected to the same points at the bottom, just so that we get new capacitors in there and we get the right look, because we want this to look original. And it'll last for a very, very long time once you do that. That's also something I've done in the building blocks, and again I'll link above if you're interested in looking at that. So that's the next step, restuffing these capacitors. And here it is, done. Restuffed with a 100 microfarad 450 volt capacitor and a 47 microfarad 450 volt capacitor. So this is as good as new, and it should last for a very long time. As you might notice, I cleaned it while it was out. The procedure took me about an hour, so this is not a quick fix. There are a lot easier ways of doing it. You can actually tack them on the underside, provided you disconnect the old one, but I prefer to do it this way because the radio looks original. Onwards. Okay, we've made some progress. I've removed the tubes. I did some checking of the power supply lines. I've done some measuring of continuity, resistance checks to the various points where the power supply is supposed to go. As I said before, I know the transformer is working. Using that test that I mentioned before, I know the output transformers are working using that same, or the equivalent test. What I want to do now is I want to check if the B plus is arriving at the various points that I expect it to be at. And I'm going to go by the schematic, follow the points that I measured continuity on and the respective resistors in line with those points. So you'll see just how much can get done by doing the power supply line check. First things first, we'll switch it on. I want to show you the usual setup is with the dim light tester. I have a 40 watt lamp only activated, the rest are off. It's active and it's off at the moment. Now I'm going to switch it on, and I don't expect any sparks. Let's see. Oh, nothing. No sparks, no nothing. Oh, yeah, it would help if I actually pushed one of the buttons on the radio. The radio is off now. Okay. Now, let's put it on medium wave. I'll switch it on here. Yes. We have the flash of the bulb as the capacitors charge up. It's drawing 90 milliamps. The indicator lights are on. So neither of those is burnt out. That's good. There are no sparks, no smoke, no nothing. So what I'm going to do now is I'm just going to measure voltages at the various points where I should get higher voltage, high-ish voltage. So I've connected the multimeter negative terminal to ground, to the chassis, and I'm just going to go through the various points by just a quick reference to the schematic, and just to see that we've got voltages where we're supposed to. Okay, it seems that all the valves, all the tubes have respective voltages, most of them very high obviously, but this one, which is the ECC85, the FM one, I should have B plus on pins 1 and 6, and I'm not getting any, and the reason's actually quite obvious once I've obviously looked at the schematic. That tube only gets voltages when you press FM. That's the FM box over there, so if I hit FM, there we go, 308 volts. So that was 1 and 6. 1 and 6, there we go. Done. Good stuff. Now, the other thing I want to check is I want to check for heater voltages, and the heater voltages I'm going to check independently because this thing has two heater lines. One heater line, it will be AC voltage. One heater line is the normal 6.3 volts, and the other one has got a hum reducer, humbucker, sort of hum eliminator potentiometer between the two. So not all of them are referenced to ground. So I'm just going to check them individually, and there is a schematic here. The ones that are referenced to ground, let's see, 4 and 5, that will be, let's see if that one's got it, 7.2 volts, a little bit high. That's the CC85. Right, we're getting B plus and we're getting all the heater voltages where we should. So theoretically we should be ready for a power up with the tubes in place, and I'm tempted to do that. I'm just going to chill for a while and have a look at this again because I don't want any blow-ups. Just make sure I'm not forgetting something obvious. Sometimes that happens. But let me just show you something curious. You've probably seen me do this. I put the PDF on screen, and then as I check things, I paint them in green. And when I get to a component that I replace, I mark it as red. If it's fine, I go through with green. Now, this is just checking the power supply. Look how much actually gets done when you check the power line. Basically, you just follow through wherever the power supply goes and check for continuity everywhere. And sometimes when you're there, for example, with the, you'll see here this cathode resistor, it happened to be in the way. I checked it, so I can mark it off. And I can go along and see how much of this is actually marked off. Because when you measure resistance from various points, starting from the power supply to the various points where B plus goes, you go through resistors, so you check their value. You go through that resistor there, you check its value. If it's fine, you mark it green. If it's not, you replace it. So before even powering up and checking for B plus at these respective points, I've actually checked these lines. And this tells me that those parts of the circuit are fine. This one actually comes on 2 pages, so the continuation of this page is over here. And as you can see, there's an overlap. I've just marked it in red. So everything to the right of this red line is already in the previous schematic page we saw. But all these markings, including some unexpected components that you wouldn't expect to be checking at this stage, and that is these coils. For high voltage to get to this point here, it actually goes through these coils. So if you measure continuity and you get continuity, it means these coils are fine. So, you know, that's one less component you have to check when you get to the next stage. So this is very useful doing it this way because it helps us to eliminate a lot of problems even before switching on the radio, and you get a heck of a lot done simply by doing this power supply check. And it's important, it's really something you can't do without, because if you have a problem in the power supply lines, the result can be quite catastrophic. I've had this in the past, shorts, and otherwise you get components that aren't getting their power. Some tubes might not be getting their power, so you waste a hell of a lot of time just trying to figure out why something's not working. This way, at least you know the power is arriving there. It doesn't mean the thing's going to work, but one of the variables has been removed from the equation. Right, next step. I'm just about ready to do the power up, the first power up, and I brought the cabinet up just to connect the speaker sockets there. You shouldn't switch this on without speakers. And anyway, I want to hear if we receive anything. So that's in place. And what else have we got? The tubes have all been put in. I've double checked to make sure I've got the right ones in the right place. That's usually something you should do. This is always a bit nerve-wracking because you don't really know what might happen. I don't expect anything dramatic. I put the knobs back in just to allow for easier tuning. I've got this connected to the dim bulb. Now, I'm going to... Oh, okay. All right. I was going to switch it off there and on here, but it's done. And doesn't seem to be any shorts. Let me show you. The lights are on very dimly. So what I'm going to do, let's see if we hear anything. It's drawing a bit more current now as the tubes heat up and start drawing current. It's drawing 210 milliamps. Don't hear anything. Oh, I heard a crackle. Yes, I've got noise. And I can hear tuning noises. Volume's on max. This dim bulb is actually drawing quite a bit of current, 200 milliamps through the 40 watt bulb. So I've got a very low voltage going through. I'm going to give it another one. And we have liftoff. As you can see, the dim bulbs are dimmer, more currents going through, 280 milliamps. The light bulbs have come on a little bit more brightly. I don't even know, the switches need cleaning. I think this is medium wave. Ha! I've got something. I've got medium wave. It's working on medium wave. Let's try, what is that, long wave? Shouldn't get anything at this time of day. But it's trying a long wave, so the oscillator is obviously working. Let's try short wave.
More of a loving than a stern father.
It's got something.
August of 1957.
Brilliant. Now the all-important one, FM. Oh, it's the inside one. Nothing. Let me give it a bit more voltage, so I'm going to put in another 60 watt bulb. I hear absolutely nothing. Even less restriction. I've got an antenna at the back. It's not that. Absolutely nothing. I wonder if it's a switch. I'm going to bypass the dim bulb tester, see if we get any better result. Here goes. Nothing. Let me put the dim bulb back on. No FM. Now that is a shame, because this is really what my main quest is to get FM working very, very well. But we'll get there. Now this would be gramophone. And that would be the tape deck. I've got no inputs on there. But the amplifier is working because we're getting sound. So the power amp stage is working. These are those tonal switches. That's stereo, mono. Okay, well look, switch that off, don't push my luck. This is actually brilliant news. The AM is working. The audio amplifier stage is working. Is it working well? Probably not. I haven't changed any capacitors here yet. Really the only component adjustments I've made here is restuffing this filter can, and we don't hear too much hum, so that seems to be doing the job. There's another filter cap at the back there. I've also reconditioned it, tested it, it's fine, and I've reformed it a little bit, and it seems to be fine. And I'm getting the all the AM bands pretty well. Well, not much sensitivity, but as I said, no capacitors have been checked here yet. The FM worries me, and it's not a B+ problem, because we're getting B+ on there. It could be the tube, it could be that the oscillator is not working, it could be that the tuning slugs aren't working. This thing works with, it's not a condenser tuner, it's actually two inductors, that slugs that fit into a core, and as you turn it, it goes further in and out, and that's how the tuning is done. It's inductive tuning. So I don't know if that's working, but for now I'm very pleased. We've had no explosions. We've had no major component faults, at least on the resistors so far, because that's all that gets measured when you do the continuity checks to check the power line. So what I'm going to do next, I don't want to stress this too much. Even though the power amp is working, the next stage is to check for coupling caps, make sure that the coupling capacitors get changed so we don't overheat the output tubes. Yeah, so that's going to be it for now. I'm very, very happy with progress, as I said, and we're ready to move on to the power amp stage and sort that out. But before I go, I just want to show you something. If you recall, these two were stuck together, and now they're not. This is the direction adjuster for the ferrite core, and this is the volume control. They're now moving independently. It took quite a bit of lubricating and cleaning inside the shafts of this potentiometer, and this basically, the shaft was stuck, the inside one was stuck to the outer one with old grease, so that had to be cleaned and lubricated, and I put it together and it seems to be fine. This is important because when you playing with AM, at least with long wave and medium wave, the ferrite antenna can be used. And the way it works is, as long as you don't have it there at the end, and as you can see there's a little arrow on there, That position connects this to the outside, the external AM antenna. The minute you move away from that, it starts using the ferrite antenna. So if you're adjusting the volume and you wanted to leave it on external antenna, if the volume was stuck, it would move it away and it would mess up what you're trying to do. Now, this works in the following way. As you can see here, there's a little switch at the base of the ferrite antenna assembly. And if I move the adjuster, so the one behind the volume control knob, this is what happens. And if you look at that switch there, look what happens when it gets to the end. It opens that up. See that? Closed, open, closed, open. In that position, the antenna that's used is the external. In that position and anywhere around, the one you're using is the ferrite. So that's how that works, and it works pretty well. Another thing I want to show you is this function on this control here. This is the FM tuning, and you can see, as I mentioned earlier, there's actually a switch in here. Let me show you how that works. To show you this, I'm going to remove these, and I'll show you what we have in the back there. This is the AM tuning. And here's the FM. Now, as you can probably see there, let me remove this. You actually have these two pieces of metal over here, and they go to the back here and they are switched in somewhere. Okay, now if you look at these two, I'll show you how they fit or how they interact with the knob, with the dial. See, this has got one metal ring in there, another metal ring in here or out here. One of those touches that one and one of those touches that one. Now let me show you when we do a continuity check. So I've got the continuity meter, the multimeter, off camera. You can hear it. I'm putting one contact to each of those, and I'm going to push in this button, short circuit. The top one, short circuit. The right one, short circuit. So whenever you grab this, you're short circuiting that. And as I said, I haven't actually looked at the schematic yet to see what this does. I think this has to do with the bandwidth, broadens the bandwidth, and when you leave it, it tightens it. I'm not quite sure. I'm trying to recall what I discovered in the previous restoration, but that's pretty neat. Very neat. Anyway, thought you might be interested. So with the last look at that offending piece of the radio, the FM section, which is not working, I'm going to close this video down for now, get started on checking the power amplifier stage, and get back to you when I've got some progress to report on. Thanks for watching. If you enjoy this, please subscribe.